I love those space videos with dramatic music that tell me mind-blowing things like the sun is 400 times bigger than the Earth, or if you were to fold up the Milky Way, it would be 20 times longer than the entire universe. They're fun, right? But they make me crave for some actual science. And today we have just the thing. A research group led by scientists from the University of Berlin has used computer models to show how water and other volatiles rain down onto Saturn from its rings. And what's more, they say that this happens so quickly that the planet could lose all of its rings in just 100 million years. Let's have a look. Saturn is the only planet in the solar system with rings. No, Pluto does not count, and these rings aren't just pretty to look at. They are an important part of the planet system and its atmosphere. The rings consist of ice crystals, rock, and organic molecules. And because the particles in the rings are charged, they interact with Saturn's strong magnetic field. This creates a current that drives winds on the planet's surface. And these winds play a crucial role for the weather and climate of Saturn. For example, there are huge storms on Saturn that have been raging for decades. And they seem to be driven by the interaction between the ring particles and the magnetic field. Then there are the beautiful hexagonal clouds at Saturn's North Pole. What makes them hexagonal is not entirely clear, but the ring particles are thought to play a role here, too. So studying the rings is important to understand the planet itself. Now, until recently, scientists thought that the material in the rings mostly slowly drifts down onto the planet, a process that's called sedimentation. But this new paper now says that there's another process that's much more important, which they call the ring rain effect. It's basically that the ring particles fall straight down onto the planet due to the gravitational pull. To see what's going on, let's have a look at the animation that the researchers made. Here you see a small section of Saturn's rings. You can see that the particles in the rings are charged, which is why they move along the magnetic field lines. The particles come in different sizes, the small ones, that's where most of the action is. They quickly spiral down toward the planet. Larger particles drift down slowly, and big, humongous particles just slowly drift around in circles. It's actually quite hard to get these motions right in the computer simulation. That's why it took the Berlin group almost 300,000 hours of computing time on a supercomputer. That's 30,000 years. Now, if you ask me, I would say that this was totally worth it because this animation is really something else. It gives you a good feeling for what's happening in those rings. But let's have a look at the results. The researchers found that while the big particles merely slowly drift down onto the planet, about half of the smaller particles eventually fall straight onto Saturn. The reason for that is that the small particles are very nimble and they can rearrange themselves on the field lines. In other words, they can optimize their motion so as to maximize the gravitational pull. The researchers estimate that particles smaller than a few millimeters across fall very quickly, within days or weeks. For those that fall within 10 degrees of Saturn's poles, they say that they reach the surface within less than a year. And then every now and then, there's this dramatic event where a particle suddenly accelerates and reaches the planet within hours. This ring rain effect changes the chemical composition of Saturn's atmosphere. The researchers found that the material from the rings increases the atmospheric density by 1 to 5%. That might not sound like much, but it's enough to noticeably affect the way that the atmosphere is mixing. And what's more, the material from the rings changes the atmospheric composition. It adds about 10% of the hydrogen that's currently in there. This hydrogen then reacts with methane in the atmosphere to form larger hydrocarbons. These hydrocarbons then form aerosols that reflect light. And this is probably the origin of the haze that we observe in Saturn's atmosphere. The researchers say that these processes are important for the energy balance of Saturn because the aerosols absorb heat very efficiently. And this seems to explain why Saturn's atmosphere isn't as cold as one would expect. It also explains why the swings in temperature on Saturn aren't as large as on Jupiter. So this ring rain effect is important for understanding the atmosphere and climate of Saturn, but it also has some other interesting consequences. If you remember, I once told you that the moon is slowly drifting away from Earth. Well, it's not drifting away, it's falling around in a slightly elliptical orbit. But anyway, this means that in about 500 million years, the moon will be twice as far away from us as it is today. This will have the consequence that high tides on Earth will be much lower in strength. This, in turn, will slow down the rotation of our planet, and it will gradually lose its orbit. At some point, the tidal force will become so weak that the gravitational pull of the sun will take over, and then bye-bye Earth. I'm not saying this to scare you. I'm just saying it's possible. Okay, but what's this got to do with the ring rain on Saturn? Well, the same process that makes the moon slowly drift away from Earth is moving the ring particles away from Saturn. This is called the tidal disruption, and this is a serious threat to Saturn. The planet's gravity holds the rings in place, but the gravitational pull of the moon, that's stronger than the centrifugal force that would otherwise keep the rings in place. So the rings are being destroyed from the outside, and the rate at which they being destroyed depends on how fast the material falls onto the planet. And that, according to this new study, is much faster than previously thought. The researchers say that the rings are being destroyed about 10 times faster than they should. And extra rain onto Saturn could make it even worse. According to the paper, the rings could disappear in only 100 million years. That's really not all that long in geological time. And even though we have never seen a planet losing its rings, I wouldn't bet against it happening. In fact, when I think about it, I find it somewhat suspicious that we haven't seen any other planets with rings. Maybe they all had rings at some time and they all lost them. In any case, the results of this study are really interesting because they show that the interaction between the rings and the rest of the planetary system is much more relevant than we thought. Thanks for watching. See you tomorrow.